Welcome to this video where we apply data science and machine learning techniques to Z-managed use cases. In this video, we're going to try OMEGAMON CICS data time series machine learning using Elastic Stack. This is Dave Willoughby. Here's a quick look at the architecture you'll see in this video. We're using all four components of Elastic Stack shown in the middle. Data is coming from OMEGAMON CICS service level analysis workspace. I have scripts that query the REST API of the TEPs every 5 minutes, create a fresh CSV of the KPIs we'll talk about later. And when that CSV appears, the beats component will push it to a Logstash. Logstash does additional processing and pushes it to Elasticsearch. And Kibana is where we do the visualization and machine learning. The inputs to machine learning is going to be CICS average response time and total transactions, and the machine learning product from Elastic Stack looks for time series anomalies. A quick view of the Logstash configuration file. You'll see some preconditioning or handling not well-formed events, stripping off the header and getting rid of lines that are not good data. A little more of the Logstash config file, the CSV column headers at the top, and then transforms of the data at the bottom. And lastly, the output stanza at the bottom. A quick view of the raw data coming from OMEGAMON, the CICS service level analysis workspace, via the TEPs REST API. You'll notice a lot of zeros in the bottom, so we ignore those, but we are selecting out the interesting columns of this sample CSV shown. Things like transaction total, percent weight on DB2, percent weight on redispatch, percent time using CPU, average response time. We also pass along the timestamp and the transaction ID, I believe. Here we've logged into Kibana, and we can see that OMEGAMON CICS data has Elasticsearch events coming in every 5 minutes. Been coming in consistently for the last month or so. I've done a search on BBOI, which is a transaction ID, and you can see in the data, if you could follow my pointer, total transactions 106 in this last 5-minute period, millisecond response time of 39 milliseconds. Further down the data we can see DB2 weight 72. Switching to the visualization tab of Kibana, I have two visualizations we can look at quickly for the data we were just searching out before. This is the average response time, pretty consistent, some occasional spikes. And then also we look at the transaction totals. Pretty consistent as well. Back on the average response time, let's zoom into like a day's worth of data. So if we go to March 7th, to the whole day of March 7th, see what that looks like. And yeah, you see the consistent response time and a little bit of spikiness. I happen to know that this CICS region restarts every so often, which could account for those spikes. And now finally, let's get to machine learning, see what that's all about. So we can switch to that view. And here's machine learning for the total transactions. You can see in the light blue, the learning process kind of picked up on this spikiness of the signal, and recent events aren't really being flagged as strong anomalies, just the light blue. We can scroll down, you can see the listed anomalies. Let's move this viewer to another time. Look for a stronger anomaly if possible. So yeah, things are running pretty smoothly. Oh, here's some red, higher density of anomalies. So yeah, those are somewhat more significant, but still I'm not sure I would have marked them that strongly. I did have a flat line outage period briefly, and it was flagged as an anomaly, but I think I've seen cases of other flat line outage periods that did not get flagged. Let's also look at average response time. Bring that up. And all those CICS region restarts where the response time spikes up are flagged as anomalies. Here's another outage period that was not flagged. Yeah, that's what we have here. So I was wondering if this machine learning could pick up on the periodicity of the restarts that happen fairly often that you're seeing. But so far it doesn't really pick up on that. I did some machine learning where I did bigger bucket sizes, and this is the result. So now you see that the spikiness has gone away. The learning process is neck down on with a smooth line at the top and bottom. The training and scoring still looks pretty similar. So now let's try adding a new machine learning job just to see what that's like. We're going to do single metric. That's the right index. Let's do average of, as we were doing before, transaction total. But let's be really aggressive. I don't know, 12 hours? The last thing I did was 30-minute buckets. Let's try 6 hours. See what that does. There's the data over the training period. So let's call this OMEGAMON total trans 6 hours. Yeah, we can create the job. Watch it start training. And it's done. Let's continue this job in real time, create a watch for it, apply that change, and let's review the results. So anyway, that's the process. We can see the training process kind of neck down as again, and then it looks like it backed off to a little bit wider margin as more data was used for training. So the 6-hour interval did actually, yeah, right, the anomalies now are few and far between as we're averaging total transactions over a 6-hour period. So averaging over 6 hours, this workload is extremely consistent. So that's it for now, time series machine learning using Elastic Stack. Thanks for watching.